Welcome to another great O'Reilly webcast. My name is Yasmina Greco. I'm with O'Reilly Media, and I will be your host for today's event. Today, folks, we have Andy Davies with us and Doug Sillars, and they're going to talk to you about what makes mobile websites tick. How do we make them faster? Andy is Associate Director for Web Performance at NCC Group, working with clients to measure and improve the performance of their websites. He recently wrote the Pocket Guide to Responsive Web Performance for 5 Simple Steps, and he's the author of the soon-to-be-released O'Reilly Media book, Using Web Page Test. Doug Sillars has been a member of the AT&T Developer Program for the last 10 years. He is the Performance Outreach Lead, helping mobile developers apply best practices for mobile performance. The tools and best practices developed at AT&T help developers make mobile apps run faster, use less data, and less battery. Folks, we're very excited to have Andy and Doug with us today to present this webcast for you all. As we get the event started, I'd like to go over a little housekeeping to help you get the most out of today's webcast. First, you'll want to open your group chat widget if you haven't already done so. This is where we can interact with each other during the event and where you can submit your questions for Andy and Doug. We find that our audience usually has a lot of good knowledge to share, so we encourage you all to chat freely during the event. However, if you have questions for Andy and Doug, please preface them with a capital letter Q so we know that it's for them and we can make sure we see it for Q&A. You can also open, move, and resize any of the other widgets. If you would like to tweet from the Twitter widget today, you might need to give it permission to access your account. The Twitter widget will automatically append the event's hashtag to your tweet so you don't have to. And today, folks, our hashtag is VelocityConf, all one word. If you have any trouble with the webcast, please take a look at your help widget. If you continue to have trouble, just post it in the group chat and one of our staff will help you right away. If you have any choppy audio or stalled visuals, please try refreshing your window. And remember, the best thing you can do for a good audio stream is to close any apps that could interfere. People always ask, so we'd like you to know we are recording today's webcast and we will have the archive ready usually within 48 hours. And folks, at this time, it is my pleasure to turn the program over to Andy and Doug for their presentation. Hello, gentlemen.
Great, thanks. So, Doug, are you going to start for us? Have we lost Doug, Yasmina?
I'm sorry, I hit the mute button so I wouldn't interrupt Yasmina while she was talking at the beginning. Sorry about that. Good morning, everybody. This is Doug Sillars from AT&T, and Andy's on the bridge as well. And we're going to talk today about what makes mobile websites tick and how can we make them faster. And we're using insights from Web Page Test and the HTTP archive. And so why are we concerned about the mobile web? Well, 85% of survey respondents said mobile devices are a central part of their everyday life. Last year, during the holiday season, over half of folks at Amazon shopped with a mobile device. And between Thanksgiving and Cyber Monday on the big shopping weekend, they sold 5 toys per second via mobile. Marissa Meyer of Yahoo says by the end of this year, Yahoo will have more mobile traffic than PC traffic. And one last stat is Etsy, 50 to 56% of their traffic is mobile. And so it's important to think about mobile because obviously that's growing and taking off. And mobile performance is really important because studies have shown that if you add 160 kilobytes of load to a page, you'll lose 12% of your audience. You get a 12% bounce rate. And if the site is slow to load, 40% will exit if the site loads in over 3 seconds, and 64% expect the site to load in 4 seconds. And then finally, my favorite stat of all is that 4% of mobile users admit to throwing their phones out of frustration when their site is slow. So When you see somebody on the train with a broken screen, it's probably the result of a slow website.
Cool. So we used a number of tools to measure the performance of these sites. And the first one, as Doug said, is we use web page test. And what web page test is a tool that will synthetically monitor a website. So you can load a website in it. It will give you a waterfall of the resources that page loads. It will show you information on each stage of the load. So you can see the DNS resolution time, how long the TCP connect time took, how long it took to make the request and get a response back from the server, and then how long the response took to download. And one of the great things about web page test is, it has desktop browsers, but it also has mobile test agents. So it's connected to real Android devices running a modern version of Chrome. There are people who provide iOS devices on it, so you can test on iPads, iPhones, and get some semblance of real-world experience. And as well as giving you a waterfall, it gives you a visual experience of the user. So it captures a film strip of the page load. And one of the things that we can do from capturing that visual image is we can create a metric called the speed index. And we'll come to a bit more about what the speed index is in a minute, but I use quite heavily when I'm judging performance. But the way we traditionally measured web page speed is we measure how long did it take for the onload event to fire after somebody requested the page. And that's fine, but that's not when our user's experience begins. Our user's experience begins when they enter the URL, when they hit the go button, and they start to see the page being rendered before them as the HTML comes down, as the CSS comes down, the browser can start to render the page at that point, and then pull in the images as they want. So Pat Meenan, who runs Web Page Test, came up with this metric called speed index, and it's a visual measure of how quickly the initial page or the initial viewport starts to render. And in the slide in front of you, you can quite clearly see there's a difference. The top one starts to render much more quickly than the bottom one, and speed index is like an inverse measurement, so it's lower is better. And the way that works is a line is a plot. There's a plot made of from when the page starts to render to when it's complete as a measure of visual completeness. And then what we do for the speed index is take the inverse of that, so that we get a lower number is better. And you can sort of see on the top two charts, the visual progress is how much is left to go is the area under the chart. And on the bottom, we actually use the area above the chart as a speed index measure. And what this does is it gives us a score, effectively, that we can use to compare websites. And that's what we did here. Then coupled with that, Steve Sowders, who was the founder of the modern web performance movement, effectively, wanted to catalog how websites were built, how we were changing the way we build websites, whether they're getting faster over time, whether they're getting bigger, how they're changing. Are old techniques like Kufon disappearing? Are we moving to web fonts? Is SVG coming along as an image format and being adopted? And plenty of people have heard about the normal HTTP archive, but there's also a mobile version. Now, the full HTTP archive has about 300,000 URLs in it. The mobile archive is smaller with only 5,000 URLs. What I haven't put on the slide here is if you want to explore the data for yourself and look at the trends yourself, is you go to mobile.httparchive.org, I believe, you can see the mobile trends. But there are some. So the HTTP archive scans roughly 5,000 URLs. It's something like 4,700 something. It uses the Akamai Moby test agent running on an iPhone that's in Dulles, Virginia, and it uses a simulated 3G network. Its download speed is 6 to 1.6 megs. Its upload is 768, and it's got 300 milliseconds of latency injected to simulate the characteristics of a mobile network. And as we all know, mobile networks are pretty high latency. LTE, so 4G, is around the 100 millisecond mark. 3G can be anything up to 1,000 milliseconds, and it's latency that has the biggest impact on web performance. So that's what the HTTP archive does. There are some challenges in that there are all sorts of sites in the mobile archive. Plenty of them are outside the US, in Russia and China, the UK, and they get some extra latency added. So this makes it a bit hard to compare sites and compare metrics. And the iOS test agent is old. It misses metrics like time to first byte. It's a bit of uses private iOS APIs to capture the data. So it doesn't measure as well as the Chrome agents do now, and there are some discussions underway as to whether the mobile HTTP archive should use the Chrome agents instead, because they can get much better information out of them and much fine-grained screen capture. And finally, the other point with it is the data is very, very noisy, as we'll come on to looking at some of the charts. So, typically the first thing we start doing with this data is, plot some histograms and look at how many requests web pages make, for example. So, we know that making more requests, particularly with high latency, slows down page load. And what we did here is we plotted a histogram of how many requests pages are making, and what we see is there are below 25 requests. There are some sites making that low number of requests, but the peak, the median of the curve is somewhere around 50 to 75. And there are people with mobile sites making 100 plus requests right up to the very end, where there are some sites that make 500 requests on a mobile site. When I originally cut this data, there was actually one site that had made 818 requests, and when I looked at the data from multiple crawls, I could see that this one site had a blip in the middle of April, where for some reason their site had become terribly unoptimized. It had gone up in number of requests. But they'd obviously seen that and brought it back down. But there are some real sites out there. So this is the Daily Mail in the UK, and it makes 500 and odd requests to load. They haven't got a mobile version, and I find it really surprising in this day and age that we still have major publishers who are not building or not optimizing for mobile, when we're using our mobile phones more and more as our network connectivity gets better, as mobile network coverages get better. We don't sit on the train and read a book anymore. We sit on the train and play with our phones and read the news. And I find it really surprising that there are some sites that aren't optimized for mobile. And one of the things this brings with such a large site is it regularly fails. So this is supposed to be a trending chart over time of Mail Online, and you'll notice that there are lots of gaps where the test for it has failed. And when I was trying to generate a waterfall for this site, just look at it, it took me 9 tests before I even got a working waterfall. So, I wonder how many people in the real world are experiencing this, and how much the Mail on Sunday suffering, or sorry, the Mail Online suffering from losing advertising revenue because they're not dealing a mobile optimized site. And this is, look at the page. This is what the waterfall looks like for this site. It's when the animation not gone too far. When it comes, it's a huge, massive waterfall, like a rocket shooting off into the sky. Yeah, so, Sunday, 8th of June, 764 requests, 9.6 meg download, and 80 domains. This is not a mobile experience we're delivering to anybody. And, so what we started then is to look at who else had similar problems.
And so if we start looking at how big mobile pages are, this is a graph showing, the count of the number of websites versus the page size. And you can see in mobile that a great majority are under 1 megabyte, under the 1,000 kilobytes. 91% of all the sites are under 2 megabytes, but there are 87 mobile sites that in the HTTP archive that measure in at over 3 megabytes in size. And as we showed with the previous slide, as websites get larger, there's also an effect of them getting slower. And so here is a graph of taking the page size in kilobytes and graphing it against the speed index. And so you can see that there's a great number of sites that kind of hit that under 10 seconds. It's very much focused kind of down here at the bottom left-hand corner, showing that the smaller the page size is, the faster it'll be. Unfortunately, there are also sites that are small in kilobyte size that are also very slow, and I've got that in the box kind of above 25-second speed index load time. The same thing happens with the number of requests. So the fewer the number of requests, the more likely you are to be fast, hence the concentration of sites down in the lower left of this graph. You can see there are sites that have a lot of requests that are, there are a few sites that have many requests that are sort of fast. I don't know if you would call them fast, but they do have a lower speed index than you might expect. But there are also a great number of sites that have fewer than 40 requests that are also very slow. And so we thought we would take a look at some of those sites to figure out what's causing these sites that are doing, the theory is make your site small, make them have fewer requests, and you'll have good performance. But what's going on with these sites here that have a low number of requests or a low number of bytes, but are still slower, over 25 seconds to load? And so here's one example of a site, and I've tried to pinpoint the dot in the graph. And the problem with this site is it has a long time to first byte. And so this site to load, you can see this is a screenshot of the waterfall, and just getting the index page, it took over 12 seconds for that to load. And so if it took 25 seconds for the page to load, nearly half of it is just starting up, getting that first HTML document downloaded and loaded so that the page can be processed. And obviously that is, the idea is you want that to be as short and as quick as possible. Here's a site that has very few requests. It has 14 requests. So this one isn't super slow. It came in at about 8 seconds speed index, or a 9,000 speed index. But what happens when this site loads up is there are a number of redirects. And so when you type in the URL, it redirects you to the secure version, and then it redirects you to a mobile version. And you eat up in the first request 900 milliseconds, and then 550, and then 450. You've eaten up essentially 2 seconds before you actually get to the request for the login screen. And so by optimizing the redirects, perhaps skipping one of them, you could easily pull off half a second or more of load time to this site. And by doing that, you will make the site pop down a little further into the lower left-hand corner of this graph. And here's a site that actually has both. It has a low request and a low byte count. But the problem that we see here is there's a whole bunch of scripts loading, and they're all shown here in orange. And each one of those scripts has to load completely before rendering can start. So these scripts are blocking the loading of this page. And there might be some head of line blocking as well. There's an image here that's shown in purple. It's request number 5, I believe. And it's very small image. If I recall, it was under 10 kilobytes, but it took a very long time for it to load. So something happened with the connection, and it may have blocked some of these other loads. But when you load multiple script files, there's only so many connections that the browser is allowed to open. And by downloading all these script files, you're actually blocking the page from rendering. Finally, I thought I would show you the opposite. And so this is a site that has a lot of kilobytes. It's 800 kilobytes. It has 163 requests. And of those requests, this is a graph from the HTTP archive showing that of the 811 kilobytes, almost 500 kilobytes are script files. And so from the previous example, lots of scripts is going to make it really slow. In this case, it actually loaded relatively quickly, a speed index of 4,500 milliseconds. So what did they do? What happened is the scripts were all loaded at the end, which is one of the best practices recommended. And when possible, they were loaded asynchronously, allowing all of the other files to render and let the browser process all of them. Now, that said, this is a neat example of a site that has a lot of requests, a large amount of data being downloaded, but it loads pretty quickly. There's still room for improvement. This site has lots of images that don't change over time, little thumbnails here and there, and there are over 105 of them. And so you could imagine that spriting those into maybe 10 larger images and using CSS to slice and dice it to show it up on the screen might actually improve the performance, because you could potentially pull out nearly 100 requests from the loading of the page. So we'll move on. And so what makes a site really fast? And this is showing the breakdown of speed index on mobile sites. This is the count of sites. And you can see that we kind of peak somewhere around 8,500 to 9,000 speed index. And so what can we do to help make these sites faster? One thing we can do is minimize the number of requests. So if we look at the speed index and group all the sites in the HTTP archive by speed index, you can get the median on the number of requests, and it grows pretty much linearly out to about 20 seconds. And it continues to grow all the way out. I think the slowest site that I saw was really slow. It was about a second to load the entire site. It just gets very, very noisy because there's not as much data out for those very, very slow sites. But it does continue to grow, and so obviously the faster the sites, the faster sites generally have a lot fewer requests. And so another thing to look at is we looked at all the sites that have a speed index of under 2,000, and what we found is that all of these sites have no external render blocking resources, so there's no external CSS or JavaScript. So in a high latency environment like mobile, the overhead of waiting for those external blocking resources does kill the performance. And so we can actually look here, and this is a graph of CSS requests grouped by the speed index. And so the numbers are pretty hard to see here. But what you can see here is this is in the x-axis, you've got your number of external CSS files that are requested. You've got the count on the y-axis. And then the blue line are sites that load with a speed index of under 2,000. And so you can see sites under 2,000 generally have 0, 1, or 2 external CSS files. When you get to 2 to 5, you can see that's in red. And we might go out to maybe, there are a few that have 5 or 6, but the vast majority are still under 2 external CSS files. And if you go out to 8 seconds, you can see the number has jumped out to 1, 2, 3, all the way out to 11. And this trend continues. I didn't want to go too far because the graph becomes really ugly, but the slower sites, you can see the number of external CSS requests just continue to grow as sites get slower and slower and slower. Another thing to look at is one way to speed the traffic to your site is to compress the files. So if the files are compressed, they download faster. And when they download faster, then the browser can render them in a more performant way, because the slowest part of this whole thing is transferring it from your server to the end user. So obviously compressing the files is going to make it come down to your customers a lot faster. And if you just look at the percent of HTML files that are gzipped for a site, and you graph that against speed index, it's really interesting. The fastest sites are somewhere around, above 70% of the files are gzipped. And the reason some of these are not gzipped is that the HTML files are incredibly small. If they're incredibly small and smaller than one packet, gzipping it isn't going to really make things faster. But if you look, it just continues to drop until you get out to the very slow sites, and we're looking at almost somewhere around 40% of the HTML files are gzipped, and it just drops very quickly. So one way to make your site faster is just to make sure that you're making the files smaller. And then another thing to look at is, in addition to the number of requests, every time you go to a new domain, there's a new DNS lookup, which is another round trip. And you can see in the HTTP archive for mobile, we have sites hitting upwards of 60 domains just for a mobile web page. The vast majority are probably under 5, under 10, but you can see that as you request more domains, and it does get very noisy, you can see the speed index increases as you add more and more domains, probably peaking out to about 15,000 after about 15 or 20 domain requests. So if you can reduce the number of domains that your site hits, you will also further speed up your site.
Yeah, and one of the things we notice with all these graphs is, as we get to the extremes, as we get to sites that are using more CSS files than the rest and more domains, etc., we've got a smaller sample size, so the data gets noisier because there's far more variation going on. But it's a lot of this isn't rocket science. We've known about gzipping text resources. We've known about reducing image sizes, putting JavaScript at the bottom, reusing connections and all these sorts of things. And despite this, we're running into worrying trends. And this is the bit that sort of horrifies me every time I look at this data, is that, although, our pages are still getting bigger, and, from 765K a year ago to 942 now, so the first of this month. So that's roughly a 25% increase in our total pages we're expecting people to download. And, it's almost as if we're expecting faster networks, better mobile devices to bail us out. But within these trends, there are some more worrying issues. So, the base size of the page, the amount of HTML we're sending, really hasn't changed that much. It would be interesting to see if all those people who haven't got gzip on, if they turned it on, whether we could, bring this transfer size down. But our base page isn't changing much. It's what we're putting in it that's changing. So, the amount of JavaScript we've got and the size of the individual files is growing. And as JavaScript is render blocking, this seems to be having one of the things that's having an impact on the visual performance. What we haven't got in this deck, but we've started looking at as well, is looking at how speed index is changing over time. So how is the perceived performance of the page is changing? And what we're seeing with that histogram we showed earlier is, as these sites are getting bigger and getting more resources, then the performance of them is degrading over time. So some of the other things we'd like to do is look at how much of this JavaScript is in the head and how much is it downloaded async or in the foot of the page. But unfortunately, we're not at the point where the HTTP archive will give us that data yet, and we haven't gone scanning for ourselves yet. But so JavaScript is growing, and JavaScript may or may not be render blocking. But CSS is massively growing, and CSS, where the media queries apply, is a blocking resource. So this will, delay this rendering of the page and give people a worse experience. Images, as ever with most pages, are the bulk of our downloads, and they are growing. But we're also starting to get some solutions for the challenge of images. So with picture and source set coming along, then maybe we'll get to a position when enough people have deployed it so that, images aren't growing so much, and the images we're delivering to mobile are well optimized for that device rather than a desktop image somebody's trying to use to cover all bases. But we tend to focus a lot on HTML and CSS and JavaScript and images in optimization work, and you'll quite often see a tweet with somebody talking about the size of this website on mobile, whether it's Oakley's 63 meg monster or wherever it was, and people focus on the images. And while that's important in terms of overall download size, one of the key things about images is they don't block rendering. The page can carry on rendering while it's waiting for bits of images to appear. But there's one resource that often the page may not be able to wait for, and that's fonts. And our font size has grown, I say 300% here based on this chart. But this is an average, and we have to be really careful at looking at averages, because when we actually plot it out, most mobile pages aren't using fonts. So, of the 4,700 odd pages in the archive, 3,000 of them don't use any fonts at all. But then, on the other hand, we get some pages that, do download fonts. And this was a desktop site. It's a Russian desktop site that somehow ended up in the archive. But they've got 1.7 megs of fonts. And I wouldn't be prepared to wait for that on a desktop, let alone in a mobile environment. But we do have sites that are meant for mobile that have roughly 500K of font files being downloaded. And these, in this situation, one of them blocks the page, one of them is loading them after the fact. And in these two sites, so Zendesk and VMware, they're using massive amounts of fonts to load, and you can physically see the effect it has when the page is loading. Linode in one of the test runs had 500K of fonts. Now they appear to be down to 100K, I believe it was. But it's almost as if we've worried about our CSS and worried about our JavaScript and worried about the HTML size, but then we've got this new shiny tool and started using it without really thinking of the balance between the user experience and the niceties that the fonts bring. And this is NBC News when it comes up. So, when fonts originally came out, we let the browser render the page as it was and then overlaid the font over the top. But we decided this wasn't a very aesthetically appealing experience. So in Firefox, it will block for 3 seconds before deciding that the font's not going to arrive and renders the page in the default font, and then when the custom web font arrives, repaints the screen with it. Chrome is just about to do something similar. But in this example here, this is NBC News loaded on my mobile phone. This is actually a screenshot of my mobile phone. And, there was a period of time where the site just wasn't usable to me. But it doesn't have to be like this. We can still have our cake and eat it, so to speak. We can still use web fonts to get a nice aesthetic experience and, still have fast loading times. So probably one of the biggest, most well-known proponents of this approach is The Guardian. If I click the right box, you'll see it. So one of the biggest proponents of this approach is The Guardian. So what The Guardian do is store their font in local storage, and then they check whether the font's available on page load, if it's in local storage, and if it is, they inject it into the page. If it's not available, they lazy load it into the background, and store it in local storage for next time. If you've ever looked at the indiephone.org site that Lara Kalbag built, you'll see that what she's done is it loads the default font, and then she lazily loads the font they want to use afterwards. There's a slight change in visual in the way that as the page is repainted, it changes slightly visually, but it still makes the page usable really earlier on. There's the JavaScript font loading library, which helps, and then finally we've got the font loading events API coming to browsers. So we can have our fonts and still deliver a great user experience. We just have to work a little bit harder at it. But there's one last thing that I would like to cover on fonts, and all too often we use the default font as comes from the Foundry. So this is Google's Open Sans font, and those are all the glyphs that are in it, and by default it's 22K. But how many of these glyphs are we really going to use on our web pages? And even by just subsetting it down to Latin, which is pretty easy to do with the Google Font Library, we can make a 33% saving. And the magic thing about getting down to under 15K is, if it's coming off Google CDN where they've got an initial congestion window set to 10, then this should be retrievable in a single round trip. And, as we know, round trips are expensive, particularly on mobile. But we can be a bit more aggressive. If we want to cut down a bit further and just use the characters we want on our websites, we can make this font under 10K. We could make this font under 10K and, if necessary, stick it as a data URI in our CSS. So, fonts are an area where we've not really pushed out the message about how to optimize the user experience, how to optimize for a fast visual loading time. And it's something from a mobile perspective we need to concentrate more on. And, it'd be interesting to see how many other people, as time develops, how many people in the HTTP archive sort of start to adopt these techniques and use a more aggressive approach to delivering a great user experience. So for those of you who've been on Twitter this afternoon, Scott Gell's been talking about something like this, where he's on this race to get the speed index for the filament group down as low as possible, doing things like inlining CSS. And one of the great things he did this afternoon was inlined the font as a data URI, so to get rid of those external requests. And it pulled the speed index down to 300 and something, I think, and there are practically no other sites in the HTTP archive with a speed index that low.
So moving, slightly changing from going into the weeds of the HTTP archive and looking at specifics for different types of requests and files. And another thing that you can do with the HTTP archive and web page test is look at design paradigms that are popular in mobile and compare them. See which are faster. See which ones use more kilobytes and more requests. And as an example here, what I'm going to show is comparing sites that use responsive web design versus sites that do a mobile redirect. And so there's a lot of stuff out there about responsive web design and how it has one site for all screens, and it just uses media queries to change the layout based on screen size. And that's kind of the 5-second overview of a very rich field of study in terms of building sites that work on all screens. And then there's the kind of I would consider the traditional approach, which is serving a mobile specific site, a site that may have a subset of information, smaller images, and probably a lot lighter. And in the examples I'm going to show here, these are sites that do a redirect to something like m.website.com. And so we've gotten some lists. Some of our colleagues have provided us with lists that they've gone through and looked at responsive, figuring out lists of responsive websites. Guy Pod at Akamai has passed on a list, and I think Andy has gotten a few lists as well. And Andy's put up a list on GitHub of all the responsive sites that we've discovered from that. And so just as an example, here is a responsive website, and it's an AT&T site just because that's easier. So if you can see, as the screen gets bigger, it changes what is shown on the screen. So this is kind of the mobile version, and then sort of the tablet version, and then it changes for the website version. And then an example of a site that does a mobile redirect is, this is the AT&T homepage. When you look at the AT&T homepage on your browser, on your computer, it looks like this. In this case, I was using Chrome and I was emulating an Android device. It redirected me to the m.att.com, and you can see it's a more simple layout. It's got these, it's got menus. It's a more simplified and smaller version of the site. And so using web page test grabs all. When the HTTP archive runs it, they run these tests, and we can then go and query and sort these sites as to what kind of sites that we see. And so we've done this 2 different ways. One is using the HTTP archive data using the older iPhone running the iOS 5. And then we also, Andy, reran those same top 1,000 sites using the Moto G running KitKat. And you can see that the numbers are fairly similar in terms of the count for mobile specific, the mobile redirect versus the responsive web, within 10, which is pretty darn close. The number of requests are also very similar. So as you can see, responsive sites, being that they are your what you would consider a traditional website just being sized down for mobile, they tend to have a lot more requests, anywhere between 20 and 40% higher, depending on the device. The kilobyte size, again, is similar for iOS versus Android. Again, the responsive websites are nearly 50% heavier than the mobile redirect sites, and that makes sense. The mobile redirect sites are designed to be lighter and to download less data. But what I found very, very interesting was that the responsive sites and the mobile redirected sites actually have very similar speed indices, I suppose. What we see in this data is that even though the responsive sites have more requests and they have more data, they actually load, according to speed index, about the same, which I found really interesting. And it could be just that the folks building the responsive sites are looking at some of the performance aspects of it, But I thought it was really interesting to see that the load times is actually fairly similar versus a redirect and a responsive site. This is obviously an area that's ripe for a lot more exploration. We're kind of scratching the surface here in this presentation. So Andy, do you want to kick off the summary slide?
Yeah, so, in summary, the crucial things about making a mobile site fast are, the things we've been encouraging people to do for a long time. You just have to do them a bit more aggressively on mobile. So it is about reducing file size. It is about reducing the number of requests, the number of domains. The big thing to watch, and you can tell on this slide who was the English-British guy who wrote part of this slide and who was the American guy by the spelling of optimized. But it's to watch what's known as the crystal rendering path. And Patrick Hammond of The Guardian's got a great talk about this, in that, once the HTML has been downloaded, and parsed into a DOM, then what happens is, it goes off and requests the any external CSS and builds a CSS object model. And then it starts to merge the DOM and the CSS object model together to build a render tree. And, it's only at that point where the render tree gets built and which we know which styles are used, that other resources referenced by CSS start to get downloaded. So things like background images and fonts. And where fonts are identified, the browsers, as we've talked about, will hold rendering. So, it's about making sure that what's in that critical rendering path is optimized as much as it can be, so that the page starts to paint quicker and people get a great experience. And then I suppose finally is, the lines responsive design appears to be, starting to deliver its promise when it's done well, in that, the lines between a mobile redirect and the mobile redirect, of course, incurs a lot of latency. So that the lines between the mobile redirect and responsive design are starting to blur, but we still see plenty of responsive sites that are well oversized, and as Jason Grigsby would put it, obese for the devices we're delivering them to. The other thing that we get to do as part of these webcasts, and we'll come on to people's questions in a minute, is, Rick Viscomi, myself, and Marcel Duran working pretty hard on a book called Using Web Page Test, because we think Web Page Test is a great tool. Some people know how to use it. Some people know how to use it on a basic level. It's got lots of great features. Some of the challenges with Web Page Test is you have to learn how to interpret the waterfalls. So if we want to get people to build better mobile sites and test better mobile sites, we've got to teach them what they're seeing. So using Web Page Test, early release is coming out soon. Full release of the book is due in the autumn, and we cover everything from getting started, running your first tests, how to use it to script, so you can script a login process on a website, for example, or script a user journey, so you can see how that loads and how effective the caching is throughout that. It's got an API, so you can build it into your continuous integration processes, and use it on a regular basis when you change code to run regular tests and see whether your performance is staying the same. And then finally, you can install it yourself. It's a bit of fun and games, but we're also going to cover that as well. So that's coming out later in the year. We've finished the main part of our talk, and so I guess it's time for questions.
All right, folks. We are now at the Q&A portion of the event, and Doug and Andy, we have several questions that have come in. Are you able to see them?
Yep, I've got them.
Super. We'll turn it back to you.
Okay, so I'm going to take Jason's question about creating a subset of web fonts. Where I did my tests on web fonts is I was using the Google fonts, which are quite popular across a lot of sites. And what you can do there is when you specify the CSS to go in, and you specify the fonts in the CSS, there's, I think it's a subset parameter, so you can specify a subset of Latin, for example, or you can specify text equals and give it an actual text string to render into the font, and that will produce the subsetted font. What you can do then, and what I know some of my customers do, is having generated the fonts that way using the CSS, they actually then take the URLs for the fonts that have been generated and embed those straight in their font face declarations in their CSS, so that they don't have the overhead of requesting that CSS sheet from Google and then having to make another request to get the font files. They can just go straight from their CSS files to the font files directly. Some of the other font foundries have subsetting facilities. I haven't found it for others as well. It's something I'm planning to do a bit more research on and dig it out, because I think it is well worth doing as a performance improvement. Doug, do you want to pick a question?
Sure. There is a question here. Does AT&T treat mobile web HTTP traffic any differently than any other data in terms of optimization and priority? And I'm not a network guy at AT&T or one of the thousands of network guys and gals at AT&T, but I would say that we treat traffic as traffic. So I don't think there's no optimization being done on our network. So what is sent is sent. There were times, I don't think AT&T ever did it, but other wireless networks did try to set up proxies to optimize traffic. We don't do that. And in terms of priority, traffic is traffic. So as it comes through, it just comes through. Is my understanding, but again, I'm not that guy at AT&T.
I guess I should probably take some of the other font questions. Craig, no, I don't know if there are any legal issues if you host Google's fonts on your own server. It's probably something worth checking with one of the Chrome dev advocates, so like Paul Kindlen or Paul Lewis or Ilya or the other Paul Irish, because some of the Google fonts are open source anyway. But to answer your question, no, I don't know any more on that. The other point that somebody makes, that Bernard makes, about the Guardian's approach of storing fonts in local storage, and people at the HTML5 comp not being too impressed about that. It's storing stuff in. People store stuff in local storage because we don't trust the browser cache. As developers, we have little control over the browser cache. We can decide, or we can declare how long a browser cache can store it, but we've got no guarantees how long it's ever going to be there. And particularly with mobile devices that are memory constrained and have small caches, then there's a likelihood they're going to get evicted more often, and so our files don't live there as long. So what we've sort of taken to do is using things like IndexedDB and local storage as a cache we can control. But there are challenges in that. So what happens when every mobile developer uses local storage to store their files and the phone runs out of space? We've taken something that the end user didn't really have to worry about, and we've made managing our cache on their device their concern instead of doing it for them. So, from an engineering point of view, I appreciate the beauty of storing fonts in local storage. I think it's only a temporary solution. I think the more people that do it, the more we will give our users problems. But I don't know the solution at this point in time. I don't know whether things like Service Worker will help us manage this in a more sane way. So I'm not quite sure how we're we do that.
So there's a question here on how speed index is calculated. And let's see if I can push to this slide here. Let's see if I can make that happen. All right, so we're going back to the beginning of the presentation. And this is a timeline of screenshots being taken by the web page test. And what we're doing is we're looking at how much of the web page is painted over time. And so you can see right here between 0 and 1 second, most of the screen has gone from white to being painted. Whereas from 0 to 1 seconds here, we've only got the headers. And, you know, anyone who's spent a lot of time browsing on mobile websites has seen web pages that sit and hang out here for a long time. And it's a little bit aggravating and it's slow because, you know, the icon of the website you're visiting is rather beautiful, and the different, you know, places you can browse on the site is beautiful, but you're really there for what you want down here at the bottom of the screen. And so what we're doing is, you know, if we want to go to calculus, you're kind of integrating the space over time that it has been painted. So here, it painted really fast, and so we have a speed index of 1200, being that on the first view and repeat views, the most of the screen is painted at 1.2 seconds. This one took a lot longer, and it took about 9 seconds for all the meat of the page, the part that you interact with, to actually load onto the screen.
But the other thing is, if you go to webpagetest.org and go to the documentation, there's a pretty in-depth description of the way speed index is calculated. And in theory, if you've got any film strip of a web page loading, you can calculate a speed index from it. There are also other ways you can do it by just looking at the paint rectangles on a screen. So you could, in theory, get a timeline out of Chrome DevTools and use that to build a speed index, although I've not seen anybody do that. But yeah, the best place for the in-depth description of how it's calculated is go to webpagetest.org and look at the documentation. So I'll take Brett's question. So web page test can capture multiple steps in a flow. It's through its scripting ability, which isn't always the most obvious thing in the world, and it sort of varies a bit between what different browsers support. But scripting ability is only available on desktop devices. None of the mobile agents currently support scripting, but you can do the login, search, view results sort of things. And if you want to do it in a pseudo mobile environment, Chrome Web Page Test has this option for Chrome where what you can do is say emulate mobile device, and it changes the request header to be from a mobile device. It alters the screen size down to a mobile viewport. It reports it as having higher DPI. So there are ways you can emulate a scripted session on a mobile device, but it's not ideal yet. So, do you want to take a question, Doug?
Sure. There's another question here, waiting for my QA to reload, but it was talking about looking at CPU usage of your mobile device while a web page is loading. And you can't do that with web page test. There are tools out there that do look at CPU usage. Qualcomm has an excellent tool called Trepin that you can download, and it shows you how your CPU is working over time as you load different things. AT&T, we've got a free tool called the Application Resource Optimizer, and it looks at network traffic, how the GPS is being used, how the CPU is being used. So you could load a page and see CPU usage over time from the from the Chrome browser or the Android browser that you're testing with.
Yeah, I'll take Bernard's question on this is all initial views. Yes, all this testing is based on the initial view of the web page, and yeah, we've done some work to look at what happens when you reload the pages. When I did the 1,000 URL test on Chrome. We captured the repeat views so we could look at what the caching behavior is. We haven't got around to that yet, but some of the things that are really sort of important to remember with caching on mobile is the caches are small, so stuff does get regularly evicted. It's probably really good for when you're on a website and you go through a series of pages. But then when you leave and come back several hours later, it's unclear how much of that stuff is in your cache. And before we have any cached content on a page, we first have to make a first view. And if we're too slow making that first view, then we're never going to get the opportunity to make the repeat view that uses the cache. Do you want to do the redirect question, Doug?
Sure. I actually don't know. Do you know the answer to that one?
It's depending on the redirect type, isn't it? Some redirects are cacheable and some aren't. It's whether the redirect is a permanent redirect, which is where I've got to remember if it's a 301 or 302, and embarrassingly, I can't do that right now.
301. But that I do know.
Yeah. So permanent redirects are cacheable. Temporary redirects aren't. The ways there are also things you can do. You can issue cache directives with redirects. So you could say if somebody's doing an adaptive design where they're redirecting based on the type of device or serving content specific to a device type, you can use cache control private so that no proxy caches cache it. But permanent redirects are cacheable.
The record I've seen, and Andy, I don't know what you've seen, but in terms of number of redirects on a mobile site, I've seen 7.
I'm on about 4 is the most I've seen. But in Ilya Grigorek talks about has a talk called 1,000 milliseconds time to glass, where he talks about what's required to basically get a page to load in a second on mobile, and Ilya makes the quote in that you just don't have time to do a redirect, because if we're operating on half a second of latency, just doing that redirect consumes most of your available time to get an experience on the page really quickly. Bill's asked a question about, is there much variation noticed in page load time of HTTPS versus HTTP only pages? Yeah, HTTPS pages are generally always slower, and there's a couple things behind that. One is the extra round trips involved in negotiating the cipher to use and exchange of certificates, and when you're on HTTPS, you have to negotiate that the initial host you're talking to. For when resources are coming from other domains, then each of those has to be negotiated with as well. And HTTPS is one of the things where we're getting better at optimizing it, but it's not as good as we could be. When I look at pages, it's often we see that the origin page, the site owners optimize their page really well, but when we look at the resources, they start to bring in from third parties, so some ad networks, some analytics, A/B testing networks. Some of them aren't as well optimized, and this has a big impact on the overall user experience. So is that the end of our questions, Yasmina?
It looks like it's the end. Folks, if you have any additional questions for Andy or Doug, please open your group chat, type it in, send it in, as we are getting ready to close out the event. So we'll give that just a moment there. And Andy and Doug, as we close the program, did you want to leave the audience with anything additional today?
Were you expecting that question, Doug?
I wasn't expecting that question.
Okay.
I think the important thing is, remember, as the world goes more and more mobile, being fast on mobile doesn't just make life better for us in developed countries or countries that have high penetration of broadband and fast mobile networks. It opens new markets to people. So YouTube, when they optimized their site, they found that, all of a sudden they had people from different parts of the world accessing it who weren't accessing it before. And, mobile commerce is becoming a thing is becoming a thing, and people buy lots of stuff on their mobile phone, on their tablets. And if we don't optimize for it, what are we doing to our sales models, and how are they affecting our sales models? And the last thing I'd probably say is, we develop on desktops. What we need to do is get out there as early on in the process and start testing and seeing what the real world experience is on mobile devices too.
I would echo everything Andy said, and the other great thing about testing for performance for mobile websites or mobile apps is that there are a lot of tools that are out there, like web page test, like the HTTP archive, like our tools at AT&T, that are all free and they're open source. And so as a developer, there's a very low barrier to actually, beyond time and getting everything set up. The barrier is actually fairly low to go and test your site or to test your native app for performance. And by doing that, you're going, as Andy said, you're going to engage your audience. You can grow your audience by hitting areas that you probably hadn't thought about before in the world. And, all of those things are good.
Excellent. And with that, folks, we're going to say a very big thank you to Doug and Andy for spending their time with us today, for giving a great presentation, and for sharing all their knowledge and expertise with us. Thank you, gentlemen.
Thanks.
Folks that attended our webcast today, we thank you for attending and hope you've benefited from it. And as we close out, I just want to let you know of a couple things I pushed out to you in your group chat. So if you didn't open that group chat, please open it before you leave. First of all, Andy and Doug will be speaking at O'Reilly's Velocity Conference, which is coming up right around the corner here, June 24th through the 26th in Santa Clara, California. And we can still save you 20% on your conference registration with code Webcast. Write that down. The code is Webcast, and you can still save 20%. Come on out, meet Andy and Doug. They'll be there live, as well as we've got lots of folks giving great talks, so we do hope you are able to join us. And finally, Andy's book is coming up here really quick for availability just around the corner as well, and you can actually get that ebook today, pre-order the print, for 50% off as a thank you for attending the webcast. So Andy's book is Using Web Page Test. And again, we want to thank you for attending the webcast, so we're offering you a discount of 50% on that ebook, and you can pre-order the print. Lots of good information in that book that can really help you with your day-to-day, so please do take advantage of these great discounts we're offering. And folks, that will conclude today's webcast. Goodbye, everybody.